What we're going to do here is we're going to find both of these. We're going to find f circle g of x, and then we'll find, I'll do it over here, g circle f of x. So let's start over here on the left side of f circle g of x. So this means if you just read it, write what you read, you get f of g of x. Now what do you do with this? G of x, what is g? Well, g is this fraction right here. Let's not worry about it, it's a fraction, so let's just put it in here. See what happens. F of, now g of x is that what? X plus 4 over 5. And now what do we do with this x plus 4 over 5? Well, we're going to process it with f. So put this, go to f right here, and replace that x with that expression right there. So we're going to get 5 times, and then what? X plus 4 over 5, so those 5s are going to cancel. And then what? Minus 4? All right, so what do we end up with here? Well, these 5s are going to cancel, right? And then we're left with what? X plus 4 minus 4, which is just x. So here's what we did. You started with x, right? Start with some number x, any number at all. You apply g to it. Then you apply f to it. And where do you end up? You end up right back where you started. So it's pretty much like we did this. We started with some number, we processed it, and then we processed it again, and we ended right back up where we started. So what we essentially did was we undid what we did. This is like an undo function. What we've done, if I draw the picture here, is this. You start with x, you process it with f, get over here to your output, and then you process it again with g, and you're right back where you started. So I'm going to say then that f undoes the effect of g. Right? You come up here, you put something in, you apply g to it, you get some output, and then you undo that output, and you're right back where you started. So f undoes g in this case. Now let's look at this problem here. Let's go with g of f of x. So this is g of f of x. And what do you do with this f of x? F of x, well, f of x is that linear function right there. So I'm going to put that in place of x. So I will get, I can write it here, g of 5x minus 4. Now, what do you do with that 5x minus 4? Process it with g. So here's g right here. So I'll replace all the x's with 5x minus 4. Right, if I put a 5x minus 4 there, I got to put it here. So right there I'm going to put 5x minus 4. So we will get 5x minus 4. And then I still have that plus 4, right? I'm putting the 5x minus 4 here, and I still have the plus 4 and all over 5. And now you can see negative 4 plus 4, that goes out, and you're left with 5x over 5, and the 5's cancel, and then you're just left with x. So in this case, it looks like g undoes the effect of f. So all in all, what we have is this. F undoes g, and g undoes f. So both these functions undo each other. And when that happens, we say this. The functions f and g are inverses of each other. So f undoes the effect of g, and likewise g undoes the effect of f. And when both of those are true, we say that these functions f and g are inverses of each other. That means they're undo functions. One function undoes the other. And here's what we could write. You know, we've got this function f. Let's see if I can write it here. We have this function f of x equals what? 5x minus 4? Now, here's what we've written up here. We've written g of x is equal to x plus 4 over 5. But if I want to make it clear that g of x is not just some other function, but these are related, right? Because they undo each other. Here's what I could write. Instead of writing that g of x, I'm going to say that it's an inverse of f, and I'm going to write it like this. F inverse of x. So when you see this right here, you read it as f inverse of x. And just to be clear here, f to the negative 1 of x is not 1 over f of x. Okay, it's not like this. X to the negative 1 equals 1 over x. This is just a notation for the inverse function. So if the function is f, the inverse I'll call f inverse of x, f to the negative 1 of x. If the function was g, I could just as well do this. If I had g, I could write, right, if I had this, g of x, I could write its inverse as g inverse of x.